In this video, we're going to go through an example of the binomial distribution. In this example, it's about darts, but it could relate to anything. And these are the typical questions you could get and shows how the binomial distribution can help calculate different probability outcomes. So John throws 5 darts. He has a 30% chance of getting a bullseye. So this is a binomial distribution. So why is that? He's throwing 5 darts. So automatically we know that for the 5 darts, that means that the number of trials is going to equal 5. Now he has a 30% chance of getting a bullseye. So we know the chance of getting a bullseye. Now what is the probability he gets all bullseyes? So there are 2 outcomes, bullseye or not bullseye. Now it hasn't said it here, but it is assumed, it has a 30% chance of getting a bullseye. So it's assumed that no matter what, it's always 30%. If he gets it in, if he gets a bullseye, it doesn't matter. It stays constant. So it should, technically I should have wrote constant 30% chance. And it'll be a bit more explicit normally in the question. So what is the probability he gets all bullseyes? So we can do this question initially using our previous probability skills. So the probability he gets all bullseyes is 3 on 10, so that's 30%, to the power of 5, which was just equal to 3 on 10 times 3 on 10, etc. So that's like a previous probability question we've done before. What is the probability gets all bullseye? So it's the probability gets 1 bullseye times the probability for the second time he gets it, times third, times fourth, times fifth. So we've done that before. So it's just 3 on 10 to the power of 5. So even though we've done it before, we can apply the binomial distribution formula and we'll still get the same answer. So we're going to say the probability of x is equal to 5. So that's basically saying that the probability of success, so we're saying bullseye is a success, is equal to 5. So that is equal to 5c 5, because there's 5 trials and we're saying 5 successes, times p to the power of 5 times q, 5 minus 5, which is just 0. So that equals 5c5 times 1 on 3 on 10 to the power of 5, which is, this is just equal to 1. So it gives us 3 on 10 to the power of 5. And you can see that this formula gives us the same answer. Yeah, so part B. What about if he gets 2 bullseyes? So we don't care about the order, we just want to know, does he get 2 bullseyes? And we need to work out the probability. So if he gets 3 bullseyes, then so I'll just be a bit more explicit in this question and say that he can only 2 bullseyes. So we don't care about if he gets 1, we don't care about if he gets 3, it's only if he gets 2 bullseyes. So this time we're saying that the probability of x is equal to 2. So therefore we have 5c2. So remember there's still 5 trials, same question, times p, which we've calculated before, it says is 3 on 10. Now this is to the power of 2. Now what is q? Well, I've already mentioned that q is 1 minus this. So it's going to be 7 on 10. Because if the chance of him getting a bullseye is 30%, then the chance of him not getting a bullseye is going to be 70%. And so that is to the power of 3. So that was 5 minus 2. So it's 5c2, 3, 2. Then we just calculate it. So 5c2 is equal to 5 times 4 times 3 times 2 times 1 on 3 times 2 times 1 times 2 times 1. Now you don't actually have to do the times 1 because obviously it's just going to give you the same answer. But for notation, you can leave it there. Then 3 on 10 to the power of 2 times 7 on 10 to the power of 3. So then this is, then you can cancel 3 times 2 times 1 with this, 3 times 2 times 1. That gives us 5 on 4, which is 20, divided by 2, which will just give us 10, times 3 on 10 squared times 7 on 10 to the power of 3. And you just plug that into your calculator and it will give you your answer. Now you can put the 5C2 straight into the calculator, but it's useful to know how to calculate it for when you don't have your calculator. Obviously if you didn't have a calculator, these numbers would be a bit easier to calculate. Alright, so the third part of this question is he doesn't get any bullseyes. So we can calculate that by thinking that the probability of x is equal to 0, which gives us 5c0 times p to the 0 times q 5 minus 0, which gives us 5c0 times q to the 5. Now what does 5c0 equal? Well, 5c0 is equal to 5 factorial over 0 factorial times 5 factorial. Now I've already said that equals to 1, so 5 factorial and 5 factorial, the same number, so it's going to equal 1. Now q is equal to 7 on 10, so 70%. So the probability of x is equal to 0 is going to give us 7 on 10 to the power of 5. Now if you remember A, we calculated what the probability was if he didn't get any bullseye. He got all bullseyes, and that was just p to the power of 5. Now it doesn't get any bullseyes is q to the power of 5. So we can see that it doesn't matter what we assign to be a success and a failure. It doesn't matter if what we assign for p or q, we will get the same answer. So that's a bit confusing. What I'm trying to say here is that we said that the bullseye was a success. And we said that was p. And so we let p equal 3 on 10. But I'm saying that you could have let a bullseye be a failure, or q, and you could have let not hitting the bullseye be a success, such as if he was your opponent, you wouldn't want him to hit a bullseye. The only thing you need to change here is that you always have to remember that whatever is a term in here refers to success. Now if you are confused here, just try and pause and understand it, but it's not overly sort of important. It's just important to understand the formula, know where they go in, and that it doesn't matter what you use for success failure, just make sure that whatever you're subbing in relates back to the very first formula I gave, and that your probabilities go in are correct, such as what we've done in this example here. Okay. Well, thanks for watching, guys. Hopefully you understand binomial probability a bit better now. We'll go through it a bit more later because the questions start to get a bit more difficult, but it's the same formula every time, and the hardest thing to do is just to identify what type of question it is.